Welcome to Roots Academy. Myself, Inayatullah, lecturer of mathematics. Student, in our last video, we discussed about passing package part 3, and in that the topic we completed is on matrix method. Chapter related to determinant and topic is matrix method. Student, in this video, we will discuss differential calculus and the topic is second order derivative. So again we are discussing passing package part 4 today, and in that topic is second order derivative. Passing package. The topic is second order derivatives. Students, very important topic in differentiation. Part D, 1 5 marks question they will ask. Part D, 1 5 marks question compulsory they will ask related to part second order derivative. So student, let us discuss the questions one by one. First question from second order derivative is, if y is equals to 5 cos x minus three sin x, prove that e square y by dx square plus y is equals to 0. Student, here the function is very simple. Y is equals to 5 cos x minus 3 sin x. This we should prove that second order derivative plus this y again should be equals to 0. So d square y by dx square is second order derivative of y function. Usually students will feel that this topic is difficult because it is related to differentiation, but believe me, it is very easy topic. Each and every student can score 5 marks easily from this topic. But for that we should know a little bit derivatives. Just if you know derivatives of some basic trigonometric functions, algebraic function, exponential function and log functions, we can easily score 5 marks from this topic. Okay, let us see this problem. So given y is equals to 5 cos x minus sin x. First, let me differentiate one time. Differentiate y with respect to x. If I want to differentiate this with respect to x, then derivative of y is dy by dx. That should be equals to 5 is a coefficient as it is. Derivative of cos. Cos is minus sin x, minus 3 is a coefficient as it is. Then comes derivative of sin x. Derivative of sin x is cos x. Student, here it completes the derivative of this function. Let me simplify. So this finally gives minus 5 sin x minus 3 cos x. d by dx is minus 5 sin x minus 3 cos x. Very simple function. Again, let me differentiate this function again with respect to x. Differentiate dy by dx with respect to x. One more time I am differentiating this function. That is second order derivative. But if this dy by dx, but taken differentiate dy by dx with respect to x. So derivative of first function is a second order derivative x square y by dx square. So that is equals to minus 5 as it is. Derivative of sine is cos x minus 3 as it is. Then still derivative of cos x. Derivative of cos x is minus sin x. If I do further simplification, d square y by dx square is equal to minus 5 cos x minus into minus plus the sin x. So student, what exactly I will do here is, I will take one minus common. I will take one minus common with this. D square y by dx square is equals to minus, if I remove minus, the third part is 5 cos x. There is a plus sign here. Plus means 2 minus. Minus into minus is plus. 1 minus I remove. 1 minus left out here. 3 minus. Inside the bracket, whatever I got, that is my y. Okay. My y is 5 cos x minus 3 sin x. 5 cos x minus 3 sin x is y. Square y by dx square is equals to minus y. That gives square y by dx square. If I shift minus y to this side, it becomes plus y. Plus y is equal to. It's very easy result it is. And actually all problems of second order derivative is like this one. Very small problems and very easy. For that we should know derivative. The very basic derivatives if we memorize, we can easily score 5 marks from this topic. Students, let us go to the next problem. Second problem. If y is equals to 3 cos of log x plus 4 sin log x, then prove that x square y2 plus x y1 plus y is equals to 0. Student, here the function is trigonometric as well as logarithmic. But log function comes under the trigonometric function. So it means here we will use chain rule. So what exactly we will do in chain rule? We will continuously multiply one by one function. So first we should find the derivative of cos by considering log x as angle. Then again derivative of log x. Actually here in the result it is given x square y2 plus x y1 plus y is equals to 0. This is, student, y1 means first order derivative, y2 means second order derivative. Y1 can be represented as dy by dx and y2 can be represented as d square y by dx square. Nothing different, just the writing method is different, that's it. Let's solve this. Solution. Given y is equals to 3 cos of log x plus 4 sin of log x. Okay, students, this is given. Let us differentiate this. Differentiate y with respect to x. So derivative of y is dy by dx, but here the symbol is y1. So I will write as it is. So it is y1. Derivative of y is y1 here because they are given in terms of y1 and y2. But if you write dy by dx, there is nothing wrong. You can write that is equals to 3 is a coefficient as it is. The student first function is cos, then next comes log function. So first we will take first. What is the derivative of cos? It is minus sine of log x. It's over. The next second under this cos there is a log x, so its derivative is 1 by x plus 4. Sine function is the first function. Derivative of sine is cos, there is log x into 1 by x. The student here 1 by x is common. 1 by x is common in both the terms. So I will take 1 by x outside. y1 is equals to 1 by x bracket minus 3 sine of log x plus 4 cos of log x. This is our first derivative. Now, student, this there is a denominator towards our right hand side. This will do cross multiplication. Whenever any denominator comes in the right hand side, second order derivative problems, that I will do cross multiplication towards the left hand side. It will be easy to differentiate. Now, if I do cross multiplication, I will get x into y1 is equals to minus 3 sine of log x plus 4 cos of log x. Just there. The moment I with the cross multiplication, then I will get two functions in my left hand side. I have a two function here. So I will use UV rule here if at all I am differentiating this term. There is a two functions which are multiplied. So I must use product rule to differentiate this. So what product rule says is first function we should keep as it is, derivative of second plus second as it is, derivative of first function. Then towards our right hand side, it is normal differentiation as we did in previous step. So if I use again differentiate y1 with respect to x, or differentiate again with respect to x, what happened to this? First function as it is, first function is x as it is, derivative of y1, second function is y1 here, so its derivative is y2 plus second function as it is y1. Now derivative of first function, that is x is the first function here, so its derivative is 1 is equals to minus 3 as it is, the coefficient, derivative of sine is cos of log x, then again derivative of log x is 1 by x plus 4 as it is. Now derivative of cos is minus sine of log x. Now log x derivative is 1 by x. First again here 1 by x is common, so we take outside the bracket. Here x y2 plus y1 into 1 is y1 is equals to, student, there is a negative in these two terms. Negative is also common as well as 1 by x. So I will take minus 1 by x outside the bracket. Okay. Next, what do you get? T cos of log x minus I remove, so plus 4 sine of log x. Now again I will do the cross multiplication, but this time I have two terms in my left hand side. This x should be multiplied to both this term. what happened? X has already exists here, so x into x, x square y2 plus x into 1 y1 x y1 is equals to minus, now students, inside this bracket whatever is there, this I can call it as y, because my y is same as this. My y is 3 cos log x plus 4 sin log x. This I will call it as y. If I shift this minus y to this side, left hand side, I will get the final answer, that is x square y2 plus x y1 plus y is equals to 0. Definitely a very small problem and very easy problem. Now students, let us go to the third problem. If y is equals to a into e power mx plus b into e power nx, prove that d square y by dx square minus m plus n dy by dx plus m into n by is equals to 0. The given function is an exponential function. It has two terms, a and b are the constant, m and n also the constant. But here a and b are coefficients of exponentials. With these functions, we should prove that d square y by dx square minus m plus n into dy by dx plus m into n into y is equals to 0. Now student, if it is an exponential function, directly we won't get the answer here, because in previous two problems we have seen that directly we got the answer. Now here in this exponential function, first we should differentiate dy by dx, then we should find d square y by dx square. After getting dy by dx and d square y by dx, we should substitute in this LHS. After substituting the LHS, if anything is possible to cancel, we should cancel, then we should get our RHS, that is 0. Okay, let us start differentiating this. Solution. Given y is equals to a into e power mx plus b into e power nx. Differentiate y with respect to x. What do we get? dy by dx is equals to, a is the coefficient as it is, derivative of e power ax is a into e power ax. So in place of a we have m, so its derivative is m into e power mx plus b is a coefficient as it is. Same way, e power nx derivative is n into e power nx. Next, this is my dy by dx. Differentiate dy by dx with respect to x. I am differentiating this function, okay, second order derivative. This is the first order derivative. So what is the second order derivative? Derivative of dy by dx is e square y by dx square is equals to a and m is the coefficient of e, that is as it is. Now again, e power mx, derivative of e power mx is m into e power mx plus b into n, is b into n is the coefficient of this exponential function. So I'll write as it is. Now derivative of e power nx, e power nx derivative is n into e power nx. So what is this d square y by dx square? am square e power mx plus bm square e power nx. Because m into m is m square, n into n is n square e power nx. Now I got all the unknowns here. dy by dx, I don't know. I got it here. D square y by dx square, I was not knowing. I know. I will take it in LHS. LHS is equal to square y by dx square minus plus n dy by dx plus m into n into y. Okay, let me substitute here. A into m square e power mx plus b into n square e power mx. This is my d square y by dx square minus m plus n as it is. What is dy by dx? Here. This I should write here. Into power mx plus bn into e power nx. Okay. Plus, I write it here, m into n. What is y? Y is the given function. Y a into e power mx plus b into e power nx. Instead, I substituted each and everything in LHS. Let me do the simple multiplication now. Then I will erase this. So, student, what is the simple multiplication? LHS is equals to am square e power mx plus bn square e power nx. And what I will do first? M into these two terms. First I will multiply minus m into these two terms. What do I get? Minus a, m into m is m square e power mx minus bmn e power nx. M is multiplied to this with minus sign, plus become minus. Now m is over. Now minus n will multiply with these two terms. Minus a mn e power mx minus b n into n is n square e power x plus this m into n I will multiply to this two terms. What do we get? A m into n e power mx plus b m into n e power nx. Now, students, let us try to cancel if anything is possible. A m square e power mx is positive here. This is negative. Gets cancelled. The next is plus b n square e power nx is positive here. It is negative here. Plus and minus gets cancelled. Next is minus a m n e power mx plus a m n e power mx cancelled. Minus b m n e power mx plus b m n e power mx gets cancelled. The student, what I got? Nothing is left out, so it is 0. This is my RHS. Student, whenever an exponential function comes, we should do like this. First, we should find dy by dx, then d square y by dx square, and we should take a left hand side, and after taking left hand side we should substitute everything in left hand side, then we should do simplification, then definitely we will get right hand side. Let us go to the next problem, fourth problem. If y is equals to 500 e power 7x plus 600 e power minus 7x, prove that d square y by dx square is equals to 49y. Very simple problem it is. It is an exponential problem, no doubt, but we should prove this very simple concept. That is, second order derivative is equals to 49 times of y we should prove. That's it. So here it won't take that much big problem as we see in the previous problem. It will be very simple problem. Let's see how can we solve this. Given y is equals to 500 power 7x plus 600 e power minus 7x. Differentiate y with respect to x. So what do we get? If we differentiate y with respect to x, so dy by dx is equals to 500 is a coefficient here, right, as it is 500, and derivative of e power 7x is 7 into e power 7x, because it is derivative of e power ax form. A is 7 here, so derivative of e power ax is a into e power ax, that's 600 as it is. Derivative of e power again minus 7x is 7 into e power 7. So here 7 I can easily take common. I can easily take 7 common. So my dy by dx is equals to 7 I will remove 500 e power 7x minus 600 e power minus 7x. Okay. I've taken 7 common from this. This is my dy by dx now. Differentiate dy by dx with respect to x. Means I'm differentiating one more time this dy by dx. What happened? D square y by dx square is equals to 7 outside the bracket as it is. 500 is the coefficient. 500 e power 10. 500. So now the derivative of e power 7x is 7 into e power 7x minus 600 is the coefficient as it is. E power minus 7x derivative is minus. This is the derivative. Now student, what I will do? Again I will take this 7 common. So if I take 7 again common, there is already one 7 outside. That's 7 into 7 is 49. 7 7s are 49. And left out is 500 into e power 7x. There is a negative sign here. There is one more negative here. Minus into minus is plus 600 into e power minus. This is my d square y by dx square is equals to 49. Inside this bracket, whatever I written, this is my y. my y. So this is y. That's it. See how simple it is? Because my y is 500 e power 7x plus 600 e power minus 7x. Very small problem for 5 marks. Go to the next problem. Question number 5. If e power y into x plus 1 is equals to 1, then show that d square y by dx square is equals to dy by dx whole square. So this is also a very easy problem, a very interesting problem it is, because here y is directly not given. So whatever it is, y is not given directly, so we should find first what is y here, then we can differentiate. And since it's very easy, first we'll do cross multiplication, then we'll get e power y is equal to 1 by x plus 1, and we know to remove exponential we will always take logarithm. So we'll multiply log, we get y value, then we will differentiate. Solution: e power y into x plus 1 is equals to 1. E power y is equals to 1 divided by x plus 1. I just divide x plus 1 on both sides. Like this. Then what can we do? Multiply log on both sides. What do I get? Log of e power y is equals to log of 1 divided by x plus 1. Now student, here log and exponential terms both gets cancelled. So y is equals to log m by n. Log m by n is what? Log m minus log n. Now student, log 1 to any base, you know that its value is 0. Y is equals to 0 minus log x plus 1. Y is equals to finally minus log of x plus 1. So this is our real value of y. From here we can start differentiating. So write differentiate y with respect to x. What do I get? Y by dx is equals to minus as it is derivative of log x is by x plus 1, and x plus 1 derivative is 1. Minus 1 by x plus 1. So dy by dx is minus 1 by x plus 1. Now let us first take the square of this. D by dx anyhow I got. Let me take squaring on both sides. Squaring on both sides. What do I get if I do squaring on both sides? I get dy by dx whole square. That should be equals to minus 1 by x plus 1 whole square. That gives minus 1 whole square is 1 divided by x plus 1 whole square is plus 1 whole square. Student, this I will start as equation 1. Okay. Now I got dy by dx. Let me differentiate one more time to this. Differentiate dy by dx. So student, if I am differentiating dy by dx, I will get d square y by dx square is equals to minus as it is. Student, this is in the form of 1 by x. And what is the derivative of 1 by x? It is minus 1 divided by x square. But here x is x plus 1 whole square. Because derivative of 1 by x is minus 1 by x square. Minus into minus is plus 1 divided by x plus 1 whole. This I will write as equation 2. Student, if I compare equation 1 and 2 here, what are same answers? So, from equation 1 and 2, d square y divided by this x square equals dy by dx whole square. Both are equal here. This problem, if y is equals to tan inverse x whole square, y is equal to tan inverse x whole square, prove that x square plus 1 y square plus 1 whole square into y2 plus 2x into x square plus 1 y1 is equals to 2. Is equals to 2. So student, here function is very simple. It's just a tan inverse x whole square is the function. And we should prove that x square plus 1 whole square into y2 plus 2x x square plus 1 y1 should be equals to 2. As we know that y1 means dy by dx and y2 means d square y by dx square. Just your representations are different. Solution. Given y equals tan inverse x whole square. Let me differentiate this. If you want to differentiate, first we should consider it in terms of x square. X square. Again, it is called as chain rule differentiation here. Differentiate y with respect to x. So derivative of y here is y1 is equals to tan inverse x whole square. Derivative is 2 tan inverse x. But again, we should differentiate this tan inverse x. What is the derivative of tan inverse x? 1 plus x square. This is the derivative of tan inverse x. Now, after differentiation, in the right hand side I got denominator as 1 plus x square. That I will do cross multiplication towards the left hand side. So we will get 1 plus x square into y1 is equals to 2 tan inverse x. 2 tan inverse x. I told in the previous problem that when we are differentiating y1, left hand side we have two terms. That we should use product rule. First function is u, second function is v. Differentiate y1 with respect to x. What do we get? First function as it is. Derivative of y1 is y2 plus y1 as it is. So derivative of first function, derivative of 1 is 0 plus derivative of x square is 2x. That should be equals to 2 is a coefficient as it is. Derivative of tan inverse. Derivative of tan inverse is 1 plus x square. Again, We simplify this. Plus x square y 2 plus 0 plus 2x is 2x y 1 is equals to 2 divided by 1 plus x square. In my right hand side again I have denominator. The denominator is 1 plus x square. This denominator I should multiply to both the terms of left hand side. So already here 1 plus x square is exists. If I am multiplying 1 plus x square again, 1 plus x square whole square by 2 as it is plus 2x is up there here. 2x into this 1 plus x square I should multiply to this. Becomes plus x square by 1. That should be equals to. How simple it is. Very easy, we got the answer. It's very small problem. The next problem. If y is equals to sin inverse x, prove that minus x square d square y by dx square minus x dy by dx is equals to 0. Very simple problem. Simply it is just sin inverse x is there and he is asking us to prove this. And in place of sin inverse it can be cos inverse also. We will get the same answers. Let's solve this. Solution. Given y equals sin inverse x, differentiate y with respect to x. What is the derivative of sin inverse x? Derivative is dy by dx equals to derivative of sin inverse is 1 divided by root of 1 minus x square. That's it. Very simple one. Now student, as I said, after differentiation, anything comes denominator towards the right hand side, that I should do cross multiplication. If I have a denominator towards the right hand side, must do cross multiplication. Root of 1 minus x square gets multiplied to dy by dx equals to 1. Now if I want to differentiate this, again I should use product rule. This is my u, this is my v. So what is product rule says? First function as it is. Derivative of second function. Second function is dy by dx. Derivative is d square by dx square plus second function as it is dy by dx. Now students, differentiation of first function. Again here is a chain rule because first it is representing root form, then algebraic. What is the derivative of root? Derivative is 1 divided by 2x into under the root it is not x, it is some other function, so we should differentiate that into derivative of 1 is 0, x square is 2x. Derivative of 1 is 0 minus as it is. Derivative of x square is 2x. That should be equals to 0 because derivative of any constant is 0. What do we get? Root of 1 minus x square d square by dx square. Now students, everything is multiplied here. 0 minus 2x is minus 2x, minus into plus minus dy by dx 2x divided by root of minus x. equals to 0. Now this 2 and this 2 gets cancelled. Left out here minus x square d square y by dx square minus dy by dx into x divided by now student, again I have a denominator here, but there is no denominator here. So this denominator I can consider as a LCM. So my LCM is root of 1 minus x square. What do I get? Okay, I should multiply this root of 1 minus x square to this. Or the other way is to cancel this denominator, I should multiply root of 1 minus x square. What do I get? I have already 1 minus root of x square, root of 1 minus x square. It becomes whole square. D square y by dx square minus dy by dx into x is equals to 0. Just multiply root of 1 minus x square on both sides. The purpose of multiplying root of 1 minus x square on both sides is just to cancel this denominator. It gets cancelled here. After that, root and square gets cancelled. Otherwise, we have write it here itself. Left out part is 1 minus x square d square y by dx square minus x dy by dx is equals to 0. For the reference, I write it here. Multiply root of 1 minus x square on both sides. This for your reference I written because you should not get confused how this step we got. How we got this step is multiply root of 1 minus x square on both sides, including this 0. Because whatever we are doing multiplication, addition, subtraction, it should go on both the sides. So it can hit on both sides. So in it is 0, does not affect. It's our answer. So student, I hope you people understood today's topic. It is very important in part T for 5 marks. Topic is second order derivative. And no need to worry about these topics because most of the teachers will tell that it is very difficult. But believe me, it is actually very easy topic and problems are all very small problems. It won't take more than 8 steps. And within 8 or 9 steps, you will get the answer for each and every problem. You can solve this problem easily. But for this, you should just memorize basic derivatives. So student, if you are new to this channel, don't forget to subscribe. To be helpful to other students, please keep sharing these videos so others can be benefited. Thank you, students.